You're welcome. I want to share with you about bearing and distance. In bearing and distance, I believe you know about uh, it's about angles, triangles in particular. So some students used to find it difficult to draw, to interpret the question correctly due to some maybe languages or whatever they are using. And I believe that once you acclimatize yourself to to those languages or terms they are using there, it will be easier for you to what to solve those questions. It's very simple. So here I want to be telling you about what you can see in the question that they are giving to you, so you'll be able to interpret them right. Now you know that this is four cardinal points. As you know that this is four cardinal points, then you know this one as what? North, east, west, and south. Then the starting point, you have a starting point, which is the north. North is the starting point. For instance, they can tell you that a boy starts from a point and move to another point, or a car left a particular place for another place. So if you hear something like that, they can tell you it may be like a car leave a particular place on a bearing of. So if they give you specific bearing, so you can, I want to tell you how they can frame that, the number of ways they can frame it. One, they can tell you that somebody move on a bearing of, so they can give you the bearing like 30 degree, 120 degree, 280 degree. Just look at this. So from the starting point, here is 90, 90, 90, 90, which is 360. So when they tell you about 30, you move on the direction of what? 30. So it simply means that from the starting point like this, you just turn 30, then you move up. So that is what that means. The same thing with 120. As you know that this is 90, so you move from here, 90 plus part of this is what? 120. So you move down like this. So if it is 280, so here is 270, so you move up like this, so it goes like this. So that is one ways they are doing what? They can give you a direction. Another way they can give you direction is for them to tell you that a man leave a point A. Let's say this one is a point A. I say and move, let's say 40 degree northwest. Look at this one. Or they can tell you you move on 50 degree southwest. As in, or 30 degree northwest. So look at this. So if they tell you that an aeroplane, a man, a girl, whoever, leave a particular point and move in the direction of 40 degree northeast. So what you have here is this is northeast. So like this. So what you simply do here is this side you consider it from the north. So here is going to be 40 degree northeast. This is north to this side. So this part will be 50 degree. If it is another point, so we consider that. So if it is another point, like 50 degrees southwest. So this is southwest, this is south. So you start from south here. So move like this. So this one is going to be 50 degree. This 50 degree southwest from this direction to this direction. So you can't put it here making this one 50 and this one 40. No, it moved from south to west. So you have it like that. Or they tell you that it moved what? From northwest. So if it is northwest, it will move like this. So here is 30-degree northwest. So you have it like this, 30-degree northwest, as the case may be. So that's the second way they can give you bearing. Another way they can give you bearing or direction is for them to tell you that an aeroplane move northwest. Maybe they tell you that it moved due northwest. They not give you any number. Is that 30, 40, 50, whatsoever? But they simply tell you that it moved northwest or southwest, as the case may be. Once they tell you that it moved southwest or due southwest, it means it divides this angle into two equal parts. In that case, you have this one to be 45 degree and this one to be what? Here you have, here is northeast. So here moving from north to east, that's 45, 45. So if it is northwest, you have it also 45, 45. And southwest, 45, 45. So that is it. So you note that. Now, that is one of the things that you have to know when you are drawing, when you are interpreting question, you draw a triangle, as the case may be, for bearing. Another thing you have to know is that if you look at textbook like what do you call it, New General Mathematics, or even some other textbook, so what you can see is that there is what you call sign bearing, and there what? There is cosine bearing. So what is the difference between sine bearing and cosine bearing? I believe you know the formula. The formula, you really know that for sine is sine A over A. Once you are given a triangle, let's say you are given a triangle like this. So ABC. So you have C, B, A. So here, for this one, for sine bearing, you can simply have this. So sine B over B equal to sine C over C. So this is the formula. They can give you anyone. It may not necessarily be A, P, Q, R, S, Y, Z, as the case may be. So you have it like this. You can equally have it inverted as A over what? Sine A equal to what? B over sine B and C over sine C. So you have it like this. You can have it either of the way. So you still get the same thing. So have it like this. But what kind of triangles you will see that you will know that you are going to apply this, because some students are confused about it. That when you draw, you see this one you are going to use, or this the other one. The cosine bearing and distance. If you want to calculate the distance, you can use this one to calculate angle or distance. So for this one, if you want to use cosine, you want to talking about cosine bearing. So you have triangle like this. So you can equally have the formula to be what? It depends on the distance you want to calculate. Let's say you want to calculate the distance. So you have A equal to what? A square equal to B square plus C square minus 2BC cos A. That's angle A. So what condition you will see? How will the shape be before you apply this or this? So you will make use of this. Look at it. If you draw your triangle, so you are given one angle here together with the side. So for side bearing, you will always be given an angle and its side. So this is the side A. Then you can be given another side. So if you are given this side, So you can use this side to calculate this. So if you are given something like this, one angle and a side, so together with another side like this, but note the angle you are given is not between this. You have this complete, or it can be in the form like this. So if you have it like this, so you have PQ. Now, so what you are given here, you have this one also, this angle. You are given this angle and this side, small p. Then look at it again. You are given this angle, this place, call this one alpha and beta. So if you are given this angle and this angle, so and you are given this and this, here you have what do you call it? You simply have a side, an angle, two sides and one angle. But here you have two angles and one side. So that this is what you have. You have this angle and one side, only one side. No any other side. Now, so that you know that this is the area you are going to have to complete on the side. Then you have that but another. So you know you are going to make use of what? Sign. That's sign. This you are going to make use of this formula. So when it is like this. But the case of this is going to be something here. So you have something here. So if this one is what? X, Y, Z. Or let's make use of the ABC that is there. So you have A, B, C. But the side you are given one angle, which is this, call this one alpha, alpha. So then you are given this side, B and C. So here, you know that this is cosine. This formula you are going to make use of. Here, what you are given is two sides and a angle between it. So that's it. If you equally draw, and when after you have drawn the bearing, the triangle, the shape, and you have this side and one angle. So you are going to make use of this. Because some students used to get confused by that. But here, this is not like none of this. This one is different from this. So that's what we are going to look at. Here, for both here, you are given one complete side and angle. Then you can be given another angle or another side. But here, you are given two sides and a angle in between. So that's how you are going to differentiate it. So with this one, I believe if they give you any question in bearing, so you will be able to solve it. So we still solve question in the maybe next class, but I simply want you to understand that what you need to know while solving what do you call it? While solving bearing and distance, or while interpreting it, because it is very, very essential. So if you don't understand where are you going to use this, where are you going to use this, so you may get confused. Some will ignore it. No, you don't need to ignore it because it's very simple. So simply look at this. So how you make use of this, how you make use of this. So they won't tell you in the exam, like in WAEC, that this one is sine bearing, this one is cosine bearing. They can still tell you in your class. But in external exam, they will simply give you a question. You are the one that will interpret it. I was okay, this is what I'm going to use for this. So this is how to identify it after you have drawn it. If you another thing is that the drawing is very, very important. So when you miss the drawing, or you miss everything, just insult, because once the drawing is not correct, there's nothing you are doing there that will correct. So you have to learn it, so how you can draw it properly. I believe the next class we'll talk about how you can draw how you can use interpret it, maybe, so you have question, then you treat it.